If you're looking to catch the April 8th total solar eclipse, you'll want to be somewhere with clear skies.
For some scientists, that means heading above the clouds.
During the 2024 solar eclipse, the WB-57 airplanes will be flying at an altitude of about 50,000 feet, chasing the eclipse shadow over the coast of Mexico near Mazatlan.
3 science teams will be using 2 WB-57 jet planes to study different aspects of the eclipse. Firstly, these 2 teams with instruments in the nose and wings will be looking at the sun's outer atmosphere, known as the corona. Scientists often study the corona using spacecraft with coronagraphs. These are occulting disks that help block out the bright sun, but they also cover up the inner part of the corona. During a total solar eclipse, the moon perfectly blocks the sun's bright disk, allowing the entire corona to appear.
A total eclipse gives us the best view of the corona we can get, and it's even better when viewed from above.
The most exciting part of using the W57 is to get over the clouds and to get to a layer of the atmosphere where it's so much less dense.
This means that you can access wavelengths of light that you normally wouldn't be able to access on the ground.
The team led by the University of Hawaii will measure different wavelengths of light using spectrometers and cameras.
Their instruments will give insight into the corona's chemical composition and temperature.
We want to figure out what kind of processes are operating in the sun just above its surface or at its surface.
For the team led by the Southwest Research Institute,
this will be their second time chasing an eclipse, so they're using an improved camera setup.
In 2024, we're flying an evolution of the experiment we flew in 2017. Back then, we flew 2 cameras in 2 different wavelength ranges. For this experiment, we're flying 4 cameras that can measure in 7 different wavelength ranges, and that gives us more information about the kinds of structures that we're going to see.
The corona could hold clues to what creates solar wind, the stream of charged particles coming from the sun that can cause auroras, but also potential threats to our satellites and astronauts. The sun can also affect technology closer to home, and the eclipse allows scientists to analyze those changes.
Beneath the plane, the team led by Virginia Tech will mount an instrument called an ionosonde to study how the moon's shadow will affect Earth's upper atmosphere, known as the ionosphere.
This is an electrically charged region of the upper atmosphere where GPS signals and radio waves travel. So during the eclipse, when the moon casts a dark shadow on Earth, scientists will see how the lack of solar radiation changes the ionosphere.
Sometimes GPS systems can be adversely impacted because of certain perturbations or variations in the ionosphere. Using this experiment, we can characterize and understand how changes in the solar radiation can impact some of these technologies that we rely on in our daily lives.
Being in the air not only gives the teams a better vantage point, but it gives them a longer eclipse too.
One of the main advantages of flying the instrument on the plane is that you'll be able to track the totality over an extended interval of time.
The jets will launch from NASA's Johnson Space Center in Houston, Texas, and travel 460 miles per hour,
allowing them to briefly chase the moon's shadow as it sweeps across Mexico and Texas.
This means the instruments will observe the eclipse 25% longer than from the ground, giving these teams a unique chance to do science.
We might not actually even know what we're going to see, and that's part of the excitement, is opening brand new discovery space and learning new things about the sun.